Hello and welcome to this beginner-friendly guide on diodes. Today we will explore what a diode is, how it works, why it has a direction, and step by step how to connect one in a simple circuit. We will keep everything clear, accurate and interesting, even if you are just starting with electronics. Diodes are one of the simplest yet most useful building blocks in all modern devices, from phone chargers to solar panels and radios. Let us dive in. Imagine a diode as a one-way street for electricity. It lets current flow easily in one direction, but almost completely blocks it in the opposite direction. This simple property makes diodes incredibly powerful for controlling and protecting circuits. The diode was one of the first semiconductor devices, and it helped start the entire electronics revolution long before transistors became common. A typical diode has two ends, called the anode and the cathode. The anode is the positive side, and the cathode is the negative side. On most real diodes, you can spot the cathode because it has a silver band or a line marked around that end. The circuit symbol looks like an arrow pointing toward a bar. The arrow shows the direction current is allowed to flow from anode to cathode. Inside every basic diode, there is a p-n junction. This means one half is made of p-type material, which has extra positive charge carriers, and the other half is n-type material with extra negative charge carriers. Where these two meet, something special happens. A thin barrier called the depletion region forms naturally, and it stops current from flowing easily. But when we connect the diode the right way, this barrier behaves differently. There are two main situations, called forward bias and reverse bias. In forward bias, we connect the positive voltage to the anode and negative to the cathode. This shrinks the depletion region, and once the voltage is high enough, usually around 0.7 volts for silicon diodes, current starts flowing freely. It is like opening a gate. In reverse bias, we connect positive to the cathode and negative to the anode. This widens the depletion region, and almost no current flows unless the voltage gets extremely high, which can damage the diode. So the diode acts like a closed valve in reverse. Here is a fun way to remember it. Think of the arrow in the symbol as an arrow that says current goes this way. Or picture a valve that only opens when pressure comes from the correct side. This one-way behavior is used everywhere. For example, diodes in your phone charger convert alternating current from the wall, which goes both ways, into direct current that only goes one way for your battery. In solar panels, diodes prevent energy from flowing backward at night. Even in car alternators, diodes turn spinning motion into steady battery charging current. Now let us build a simple practical example step by step. We will connect a diode to protect an LED and make sure current only flows the correct way. You will need a 9-volt battery, one ordinary silicon diode like the one N4007, a red LED, a 330 ohm resistor for the LED, some wires, and optionally a switch. Here is exactly how to do it. Step 1. Connect the positive terminal of the battery to one end of the switch if you are using one. Step 2. From the other side of the switch, connect to the anode of the diode. Remember, anode is the side without the band. Step 3. Connect the cathode of the diode, the banded side, to the longer leg of the LED, which is usually the positive, anode of the LED. Step 4. Connect the shorter leg of the LED, the cathode, to one end of the 330 ohm resistor. Step 5. Connect the other end of the resistor to the negative terminal of the battery. When you close the switch or connect power, the LED lights up brightly because current flows through the diode forward, then through the LED and back. Now try reversing the diode. Swap its two ends. The LED will not light up at all because the diode blocks the current. This shows protection in action. If you accidentally connect the battery backward, the diode stops harmful reverse current from damaging the LED. Diodes come in many types for different jobs. There are rectifier diodes, like the one N4007, that handle higher currents for power supplies. There are fast switching diodes, like the one N4148, used in signal circuits. Light-emitting diodes, or LEDs, are special diodes that glow when current flows forward. Zener diodes even allow controlled reverse flow at a specific voltage to regulate power. Each type builds on that same basic one-way principle. Real-world examples make diodes exciting. In almost every USB charger, multiple diodes turn wall power into safe phone charging. In your television, power supply diodes convert AC to DC. In guitar amplifiers, diodes shape the sound for that warm overdrive effect musicians love. Even simple solar garden lights use a diode to stop the battery from draining back into the panel when it is dark. Tiny invisible diodes protect your smartphone ports from wrong polarity connections every day. To summarize, diodes are the ultimate electrical check valves. Always check the band for the cathode. Connect anode to positive in forward direction. And use them to direct current protect components or convert power. Start with this simple LED plus diode circuit on a breadboard. Play with reversing things to see the blocking magic. With this understanding, you can now experiment with rectifiers, protection circuits, and even basic power supplies. Thank you for listening and enjoy building. This has been your complete, easy-to-follow introduction to diodes. Happy experimenting!